Okay, hello everyone. Welcome to my channel. And in this video, we are discussing about GFG problem of the day, that is power of 2 and subsequences. So this is a medium level question. So let me just brief you about the question. That is, given is an array of size n, and we have to return the number of non-empty subsequences such that the product of all the numbers in the subsequence is power of 2. And since the answer may be too large, return it modulo 10 ki power 9 plus 7. Pretty cool. So what basically the question states, first of all, we have to like find the number of subsequences. So what are the subsequences? You all may be knowing that subsequence is a set of numbers in an array such that suppose I am taking two indexes I and j, and such that our index I is smaller than j, and we are taking elements according to that particular order. And in the subsequence, it is not necessary that our element should be in a continuous form. Like suppose you must be knowing that, but I am explaining you once more, like 1 2 3 4 5. So if I want to like make a subsequence, so it may be 1 3 5, right? And but if I want to make a sub array, so it must be continuous, like 1 2 3 4, like this type of thing, right? So this, I hope you understand that. So let me move on to the further. So like there is a condition that is given, like we have to find the number of non-empty subsequences. Like the subsequence is not should not be empty, and such that the product of all the numbers in the subsequence is the power of 2. Now it is given that the subsequence we are making should like the products of all the elements that are in the subsequence like should follow a condition that the product should be a like power of 2, right? So this is the condition. And finally, when we are getting our answer, we just take a modulo by 10 ki power 9 plus 7 so that it does not overflow. So let me just like tell you like how will you approach the question if you are like find this question anywhere, right? So what I will do, so suppose I am taking the example of this 1 6 and 2. Now if I like notice here that I am in this array there is a element that is 1. So like 1 is a power of 2, that is 2 ki power 0 is 1. So like it may be treated as independently as a subsequence. So like it will increase my count of the count by 1, like where count is the number of like subsequences that satisfy the condition, that is the products of all the elements in the subsequence should be a power of 2, right? Now if I move on to 6, now I will notice that 6 does not like satisfy the condition, that is it is not a power of 2, right? Now if I move on to 2, I will see that 2 is a power like of 2, that is 2 ki power 1. So it may be treated as a element single element subsequence, that is like I can take only 2 as my subsequence, so it increments my count by 1. So my count will become 2, right? And now like I have taken all the like single elements, I have checked all the single elements type, like I have checked like all the single elements that may like follow the condition, right? Now subsequence may have single element, may have a pair and may have a triplet and any number of elements, right? As far as it like follows a particular given condition. So like I have 1 and 2 as two subsequences. Now it may be possible that 1 and 6 may form a subsequence, or 6 and 2 may make a subsequence, and 1 6 2 like they all make a subsequence. So let me check, like if I take 1 and 6, the product is 6 and this is not a power of 2, so I neglect it. Now I will move on to 6 and 2, its product is 12, it is not a power of 2, so I will neglect it. So if I take like 1 and 2, like 1 and 2, so this 1 and 2, so their product is 2, so it is a power of like 2 ki power 1. So I will take it in my subsequence. So my count will increment and will become 3, right? And if I take 1, 6, and 2, all the elements together, so the product will be 12, and this is not a power of 2, so I will neglect it, right? Now this is the first case, and my count is 3. So and the same is the answer. So I will return a 3. So now I will move on to the next example, that is 3, 5, and 7. So the same procedure I will follow as in the previous example. I will check if 3 is the power of 2. It is if it follows a particular condition that is given in the question. So I will like find out that it does not follow the condition. So I will just neglect it for single pair, for single element subsequence, right? Because first of all, I am checking that if a particular element can make a subsequence if I only take that particular element only. I am not considering any pair triplet in the first case, right? So now I will move on to element 5. I will check that is it follows the condition. So like it is not a power of 2. So I just also neglect it because it does not contribute as a subsequence, right? For that particular condition of the power of 2. Now I will move on to 7. I will check that whether 7 satisfy the condition like it if it is a power of 2. So I will like uh, find out that it is not a power of 2. 7 does not satisfy the condition that 7 is not a power of 2. So I will just neglect it, right? So I am not getting any single element that may be treated if I take a single element as a proper subsequence for my condition, right? So I have checked for 3, I have checked for 5, I have checked for 7. I do not find any single element that like follow the particular condition for itself, right? Now I will check for pairs. I will just group the pairs. Now I will check like if that pair or triplet will satisfy the condition. So let me just tell you, like I will take 3 and 5. So the product is 15. Now it does not satisfy the condition. I will take 5 and 7. It is 35. It does not satisfy the condition. I will take 3 and 7. That is your 21. It does not satisfy the condition. If I take all the three, so this is 35 into 3, 105. That does not also satisfy the condition. So and 3 and 5 I take 15. It does not satisfy the condition. So I will notice one thing from this example, that like for like we in this example we see that if I do not have any single element, that is basically a power of 2. So no matter I can pair it with any other element, I do not find any product that is a multiple that is a power of 2, right? So to make for a pair or for a triplet or any number of elements, to make a product that is basically power of 2, so that to make any number of elements, maybe it is a pair or a triplet or any number of elements like in a subsequence, to satisfy the condition that the product should be a multiple is a power of 2, then we have to ensure that all the elements in the subsequence should independently be satisfy the condition that they must be a power of 2. Not understanding? No problem. Let me show. Like suppose in this example, what I'm trying to explain, like if my 3 is not satisfying the condition, 5 is not satisfying the condition, 7 is also not satisfying the condition. So no matter how I pair these 3 elements or 2 elements, no matter, because if I do not find a particular element as independently the power of 2, as soon as I do not find it, I will not be able to find any pair or a triplet or any number of elements subsequence to satisfy my condition. So I just have to first check that if my elements satisfy the condition independently. If any of the elements, if like all the elements does not satisfy the condition, so I am pretty much sure that I will make a pair or triplet. It like does not follow the particular condition, right? So I will make any pair or triplet in this condition. It does not satisfy. I just have a diagram so that you can understand, right? So basically this you will understand, right? Now here is one another case, like suppose I am taking the example of this. Let me one example I will take is at suppose 3 2. Suppose this is an example right? So I will check for 3, it is not satisfying the condition. 2 is satisfying the condition, 6 is not satisfying, 9 is not satisfying, right? Now, like I'm getting a pair, I'm getting a subsequence of independent 2, so I will increment my count with 1, right? Now after that, the second step is that after I check a particular elements independently, now I have to check like how can I pair the, or make a triplet, or make any number of like elements together such that the product also satisfy the condition. So I will notice one thing here, that uh, if I like pair these elements 3, 6 and 9, that does not satisfy the condition. As I told you earlier, if I pair in any of the way, like 3, 6, 3, 9, or 3, 6, 9, the product does not satisfy the condition also, because what is happening for I have told you earlier that for satisfying, like, because I have told you earlier that to satisfy this condition, like for a subsequence, you must be knowing one thing only, right? This the crisp of the climax of the particular question lies in the saying that to make a subsequence in which there are multiple elements, and all of the like, and the subsequence should follow a condition that is given in the question, then all the elements in the subsequence should independently follow that particular condition. Like the all the elements in the subsequence should follow the condition that independent elements should also be a power of 2, correct? So I will just notice if yeah, this example. So if I am trying to make a subsequence having 3, 6 and 9, 3, 6 and 9, any of the elements, I will not be able to make any subsequence like that is following the condition. So that's is pretty much simple. But if I pair 2 with any of the elements, then the same also condition holds, because the product will also do not make like the condition true, because 2 is uh, indeed like following the condition, but the other elements like 3, 6 and 9 do not follow following the condition. So my product will not be a power of 2. So to make a subsequence of any number of elements that follows a particular condition that the product is a power of 2, then all the independent elements should be a power of 2 independently, right? This is the basically question. So I hope you understand the algorithm what I'm trying to explain. So let me like deep down into the code, and your further problems will be like solved in this. So what I have done is that I am taking a long mod 10 to the power 9 plus 7, and I am taking a count. Now why I'm taking this count? So this is to take account of the number, like the number of single elements that follow the condition, right? The independent elements that follow the particular condition, because in the first pass I am like just checking like how many elements if taken independently can follow the particular condition. So that's account for our count now, right? Now I will move on to this line. So this is long answer, so I'm taking it as my answer that I want to return as number. This is basically accounting for number of subsequences, right? Now what I will do, I will just do this operation that I have told you. I will just traverse over the array, and I will for each element I will find out that if this element can be treated, if this element follow a condition that it satisfy that it is a power of 2 or not. So what I have done is that I am using a bitwise operation to do it to do this. I will explain this to you in a while. So let's assume that let me let me give you an example, the same example in this like 162. So like after this line, what I will have is that I will have a count of the elements that will satisfy the condition that is they are a power of 2. So my count after this for loop is over, after my this for loop is over, my the count will basically store the value of, like in this case, 1 and 2 both satisfy the condition, so count will become my count will become 2 after this for loop. I will show how this will work. So now what will I do? So now I will have a count, like how many elements will follow the condition independently. Now how will I like calculate the number of subsequences like that can be made? So the question boils down that we have a number of elements that follow a particular condition that I have find out as a count. Now I will have to find out like how many subsequence can I make from that particular elements, right? So if I tell you that that's I am taking an example that for this example 162 I have a count of 2 and I am getting an answer 3. Number of subsequences 3. And in the second example 357 we are getting a count of the elements that follow a particular condition as 0 and we are getting an answer 0. And if I take an example of this 4289 4289, right? In this example we are getting three elements 4, 2 and 8 that satisfy the particular condition, like 4 is the power of 2, 2 is the power of 2, 8 is the power of 2. So we are getting count as 3, and if you draw all the subsequences you may get answer, you will get an answer of 7. You may try run over the test case and you will get to know more about it. So what I'm like it is basically sequence that is observing, you may be understanding, right? For 2 it is 3, 0 for 0, 3 for 7. So you may notice that for if we have a count of n, then we can make a total of 2 ki power n minus 1 subsequences, right? So what I have done is that I have a count variable. I have to calculate 2 ki power n minus 1. So what I have done in this while loop, I am calculating 2 ki power n. So like what I will do, I will just iterate like over I will just iterate while my count is greater than 0. And what I will do at every step, I will just do answer is equals to answer into 2 modulo mod, because it may happen that at any condition my answer may overflow. So I am taking condition take care of that. And now I will count minus minus I will do, and I will return answer minus 1, because 2 ki power n minus 1 we have to return, right? Now this is pretty much clear. Now this condition is there, like how will you calculate like how many elements are basically a power of 2? So it basically it is a very simple thing, you may be knowing that. So suppose I have a number that is basically 8. So I have to check that it if it is a power of 2 or not. So let me have a binary representation of that number. So it is basically so it is basically the binary representation 0, 1, 2, right? So for 8 the binary representation is this, right? And suppose what I have done is that I am taking AND operation of particular that element and the element just previous to it, right? So I am just taking an element like 7 for that case, and the binary representation of 7 is 0, 1, 1, 1. 2 ki power 0, 1, 1 plus 2, 3, 3, yeah. So this is our and binary representation of 7. And if we AND both like 8 and 7, we will get a 0, right? So like we will just have a look that 8 is a like even number. So what is the basically gist of that? So basically in if we have any even number, if we have any number that has that satisfy the condition that is the power of 2, so that particular element has only one set bit, that in this case, and the element that is just previous to it has all the other bits set instead of that particular bit that is set in that number, right? So in this one is set here and all other are 0. In the 7, that is one previous number, all the other bits are set instead of that particular bit that is set in 8, right? So if we AND both these numbers, we are getting 0, right? So this is a condition. So we have like this is basically pretty much understanding, right? If you have done this question, you may be knowing that. Otherwise I have explained you small like how you calculate that for a particular element. You may calculate that if that number is the power of 2 or not. So if it is a power of 2, if it is satisfying the condition, so I will just increment my count and move on to further conditions, right? So I think that this question may be like understandable to you in a pretty much better way. So if you like understand this question, do hit the like button and share among your friends, and subscribe to my channel, and I will meet you in the next video. Thank you. Bye.